Okay, so this video is on part of Chapter 6 that covers aquatic biomes. We talked about terrestrial biomes in class, so here we're going to go into aquatic biomes. So there are two major divisions of aquatic biomes. There's freshwater and saltwater. And the kind of categories of organisms in these water habitats are plankton, which are free-floating organisms, and that's essentially what plankton means. They don't necessarily have to be small, but it just means free-floating. And then nekton are strong swimming organisms that basically can swim against the current. So that would be fish and anything that can really swim on their own. Plankton kind of float in the water. And then there are benthos organisms, and those are those that live on the floor of either the ocean or a river or a lake, things like clams and that sort of thing. Okay, so freshwater ecosystems. So again, we're going to go into freshwater first and then saltwater. And these include rivers and streams, lakes and ponds, and then marshes and swamps. And together they represent only 2% of the Earth's surface. But they're very important because if you think back to the water cycle, these freshwater ecosystems are what carry water back to the ocean, and you know, they play a key role in the water cycle, where rainwater is collected and then cycles back. Okay, so to start with rivers and streams, I have a nice diagram here of a typical river, and there are two kind of distinct types of habitats within a river. The first are these headwaters, and this is, oops, let's see, pointer. Okay, so the headwaters are up at the top, and they are very cool. You know, they're higher in altitude, and they're also coming from snow, potentially snow on a mountain. And they're steeper, so they're flowing more quickly. They're highly oxygenated because this water is kind of going faster and it's going over rocks, and so that kind of mixing with the air creates a habitat that has more oxygen in it. And these characteristics are going to make it, you know, a very different habitat for different organisms when you compare it to the mouth of the river. And so the mouth is going to be this area, closer to the ocean, and it's going to be warmer. It's lower in latitude. It's, you know, farther away from the original source of snow. It's slower flowing. It's flatter. It also tends to be broader, and it's less oxygenated. It's, for the reasons I mentioned before, kind of the opposite of that. It's not flowing as quickly, and so you're not kind of mixing it up with the atmosphere as much and getting as much oxygen in it, and also it's warmer, and oxygen is going to evaporate from the water more quickly. Okay, so that's rivers and streams. Now onto lakes and ponds. They experience what's called thermal stratification, and it's basically the idea that the lake is going to be stratified or separated out. You can see kind of right here. And then if this was a more exact on actually the temperature, it separates out based on temperature. And this you can see is a graph of a thermocline. And that's a term you should definitely know. So a thermocline is basically when the temperature changes sharply over small depth changes. Okay, so what does that mean? Well, if you look here at the water depth, okay, so this is, you know, very shallow. So this is like the top of the lake, and as you go deeper and deeper and deeper, this is the temperature. Okay, so as you would think, the top is going to be the warmest. Just like in the ocean, it's closest to the air and the sun and all that. Okay, so as you go down deeper, it's going to get cooler. So here you have the warmest temperature here, and as you go deeper, it's going to get cooler. Well, what this thermocline is showing is that you're not changing the depth very quickly. Okay, so you can see that the depth is staying right here. It's pretty much the same. In actuality, it's changing very slowly. It shouldn't be exactly flat. But the depth isn't changing very much here, but the temperature is. Okay, so that's basically showing that in a very small time frame, a very small space, you're going to drastically change temperature. And so this is kind of what you would have here. So in a very small space, you're going to go from warm to cold, and you're not going to change depth very much. And that's called thermocline. Okay? Alright, and so something that is very important in lakes is called annual turnover. I'm just underlining it because I know that's extremely helpful. And it's this process where lakes kind of rotate the water and mix up the water. And it's really important, and you can kind of equate it to the global the Great Ocean Conveyor Belt in the ocean, where you have this mixing of water. So oxygen is brought down to the depths of the lake and nutrients are brought up. And wind and temperature are kind of temperature changes are what drive this mixing. So in the summer, you can see you have pretty steady water. The thermocline develops here. You have warmer water on top, colder water on the bottom. And in the fall, as the winds pick up and the water gets colder on top, the water is going to start the water on top is going to start to sink as both it cools and also as the winds kind of blow it around. Okay, and then in the winter you're going to get in most places, well, not most, but in temperate places where it gets cold enough, you're going to get ice on the top. That's actually going to form a nice kind of insulating layer for the folks underneath that can still live in the water. Okay, and then in the spring, as this water warms, it's going to rise to the surface, and also winds are going to help mix it up. So you basically get this constant circulation that's really important for lakes. And if you remember, I mentioned it in all classes. I wasn't able to show it to most classes, the part where Ian Stewart in one of the videos talks about Green Lake in New York, and in New York State, and this lake basically does not have turnover, and so what happens is the bottom is completely devoid of oxygen, and you're starting to have some really kind of crazy effects going on where there's all these anaerobic bacteria that live down there and producing sulfuric acid. And basically the main point is that it's a very unhealthy lake now because you don't have this turnover. Okay, so just to reiterate, that is important for health of lakes. Alright, and lastly, marshes and swamps. These are areas that are shallow, and fresh water covers the land and the plants here for part of the year. Marshes and swamps, what's the difference? Well, marshes, they both obviously have this characteristic. Swamps have trees, marshes don't. That's the main characteristic. And both of them are kind of shallowy areas. You know, this is a nice looking swamp here, where fresh water is covering the plant life there for part of the year. Okay, and because this water is there, it's very waterlogged, and the soil is anaerobic, meaning that there's not any oxygen in the soil. And these are the kinds of conditions where coal, well, I'll get into that next unit, but coal is formed in these types of anaerobic conditions where you had a lot of plant life. Okay, so marshes and swamps are very important for you know, these different ecosystem services. And these are areas, if you, I'm kind of hesitant, let me go back to the rivers. So this type of area here is going to be a typical area for a lot. This low-lying area here is going to be a typical area for marshes and streams. Marshes and swamps. Kind of as it's going out to the ocean, you get